Thank you for that presentation. Now, a look at what's keeping AI up and running as demand accelerates. I invite Bar Ben Horin, VP of Product at Carrar, to talk about powering the AI boom with next-gen battery systems innovation.
Hi, hello. My name is Bar, and I'm Carrar's VP Product. Today, I'd like to talk about the hottest topic of the decade, how to power the AI revolution. Hyperscalers are willing to pay a fortune for the data centers to train, to run their AI models. Forecast shows that by 2030, about 10% of the US electricity will be consumed by those AI data centers. Those giants understand that whoever wants to go up on top of the revolution needs to invest, and not only invest in software and in computing, also invest in the infrastructure to support the data centers and keep them up and running. The biggest challenge we see is grid connection, the size, and the stability. The data center is built, the perimeter signs, but where is the grid connection? It's simply gone. Even if you somehow do get connected to the grid, there are issues with power stability, and voltage swings are killing the GPU performance. So power stability is everything. $9,000 per minute. $9,000 per minute for downtime. Right? It's only an average. All right? For hyperscalers, this number is far higher. Operators used to offer 3 nines, 4 nines SLA, but because of this downtime cost, the bar is just increased, right? We are now at 5 nines, even 6. It means minutes, even seconds of downtime per year. So energy storage system sounds like the answer, aren't they? BESS are definitely becoming a critical infrastructure. The problem is that conventional system became a commodity, and those systems have 5 key challenges. There are safety risks, environmental condition dependency, performance limitation, short lifespan, and high L costs. Those commodities cannot address those issues. We need to find a different approach, a fundamentally different approach to tackle them. We cannot just wait to the perfect chemistry to emerge. I'd like to present a quote that I think captures this perfectly. What does battery chemistry have to do with battery safety? Not as much as many believe. Chemistry sets the baseline. Chemistry sets the boundary conditions. But still, the system is the one that determines the outcome. Peter is a former Norvelt executive, and I believe he's seen far more battery failures than anyone else. And his point is exactly where Carrar starts. So how does it look like when you build a battery system where all aspects are considered since day one. Carrar has 3 layers of proprietary IP that acts as one complete architecture, 2-phase immersion architecture. So how it works? The first layer, the nucleation IP, the battery cells are being submerged in a dielectric liquid, right? We solved the boiling. We solved the physics of boiling, and heat is being removed from the very source where it generated. It's not conducted through endless layers, just removed from there at the source. The second one is the module design. The cell housing, the bus bars, liquid, vapor management. We took them all and co-designed it to a single unit. The safety isn't bolted on. It is structural. And finally, the thermal management system, which is a closed-loop, self-regulated, and at normal conditions, it's almost passive, right? No parasitic energy. No HVAC is needed, no cooling towers, no water, right? No water at all. The result of this architecture is a set of advantages that conventional systems simply cannot match. No thermal runaway, absolutely 0 safety events, 50% higher peak power, no lifetime compromise. It isn't a marginal improvement, right? It's a different product category that can transform project economics completely. Carrar is genuinely doing something no one else can do. Takes, for example, the BMS, the battery management system. There are usually 3 variables to control the batteries: voltage, current, state of charge. Every system in the market are using those. Carrar add the 4th parameter, the temperature. We can actually physically control the temperature, not just monitor. And therefore, it can be additional control input to the system. This is where energy and AI relationship actually getting stronger, right? We are not only powering the AI, we improve it, and it improves us. It unlocks optimal charging and discharging protocols that has a perfect hardware to software combination. So where does it leave us? AI data centers deserve real solution. Carrar is the battery system that the AI era demands, and it exists today. Thanks a lot. Appreciate your listening. If you have any questions, you are more than welcome to approach.